So hey guys, welcome back to my channel. Hope you are doing extremely well. So let's continue our GFG problem of the day series. And today's problem is largest rectangular submatrix whose sum is 0. So without wasting any time, let's see what does the problem say. So the problem says given a matrix as input, in the output you have to provide a matrix whose sum of elements is equals to 0. Also, the matrix should have maximum number of elements present. What does this mean? Suppose if you have two matrices whose sum is 0, one is of size 4, that is 4 elements are present inside it, and another one is of size 8, then you have to give the priority to the size of 8. Okay. So in the above given matrix, can you find any some matrix whose sum of element is 0? Let me point it out for you. I think you will be able to locate now. If you look at the matrix given, I have highlighted 1 plus 2 plus 3 minus 3 minus 2 minus 1, which is equal to 0. This is our answer in this case. Okay. Now, how could we arrive at this answer? Let's discuss the different approaches. So, at first we can discuss obviously the brute force approach. So, what does this approach say? The first step is generate all the submatrices possible. Second is calculate the sum of the corresponding submatrices, and the third one is to return the answer which satisfies the given conditions. I think the steps are pretty straightforward. Now let us analyze the time complexity and the space complexity. Time complexity. For time complexity, can I am trying to make it a really simple for you to process the time complexity. Okay. So now, can a subarray, can an array of size n be represented as a matrix of size 1 cross n? Okay. Now, can submatrices formulation be related to subarray formulation? That is, can I say finding subarray is analogous to finding submatrices? The answer is yes. Okay. So to find subarray, we already know we require term of O of n square, and similarly for finding submatrices, we would require a term of O of n into m square, where n cross m is the order of matrix. Okay. This is for formulating all the submatrices possible. Now to calculate sum of all submatrices possible is, what would it be? It would be O of n into m. Okay, because you will have to traverse all the elements of the matrix. So what is the time complexity in overall? That is O of n into m whole cube. I think you agree with me. Okay. Talking about the space complexity, it will be O of one because we will be keeping the account of only the matrix we have got in answer, and we will keep updating that answer. Okay. Now because of the high time complexity, we will have to discard the brute force approach and find an efficient algorithm. So let us move on to the efficient algorithm. Okay. Pay attention now. It says 1, 2, 3, minus 3, minus 2, 1, 1, 7, 5. Can I say if sum of submatrix is 0? This is our main goal, right? So let us consider the submatrix is this. Let me write it down here. 1 minus 3, 1, 2 minus 2 minus 7. I am saying we have to find the sum of this submatrix. Okay. Can I do it like this? The sum of this submatrix is 1 plus 2 minus 3 minus 2, 1 minus 7. The sum of this submatrix is equal to sum of this submatrix, this matrix. Is it correct? I think it is correct. What I have done, I have added the element in the same rows. Now this would be 1 plus 2, it would be 3 in the first element, minus 3 minus 2, that would be minus 5, and minus 1 minus 7 will be minus 6. That is equals to 3 minus 5 minus 2 minus 8. Okay. So this is my approach here. I will use this kind of strategy. What I will do, the matrix given to me is 1, 2, 3, minus 3, minus 2, minus 1, 1, 7, 5. Okay. What I will do, I will try to find all the sub-arrays along the columns like this. Sub-arrays possible, I am writing them. This is a sub-array possible. This is a sub-array possible. This is a sub-array possible. Then this is a sub-array possible. Then this is a sub-array possible. Then this is a sub-array possible. Am I correct? I have highlighted them. Okay. What will I do? Suppose for this one, what will be the row wise sum? Like I depicted here, no? This one. Can I calculate it here? Yeah. For this one, which I am highlighting here, what will it be? 1 minus 3, 1. Okay. What will be the row wise for this one, which I am highlighting now? It will be 1, 2 minus 3, 2. That is 3 minus 5, 1 plus 7, 8. Okay. Now for the third one, it will be 1 plus 2 plus 3, that is 6. Minus 3 minus 2 minus 1, that is minus 6. 1 plus 7 plus 5, that is 13. Then next one, this, that is 2 minus 2, 7. After that, one below it, that is 2 plus 3, 5. Minus 2 minus 1 minus 3. 7 plus 5, 12. And then the last one, that is this one. That is equals to 3 minus 1, 5. I say, what I'm saying is, suppose, take this example. Okay, that is 6 minus 6, 13. I am saying if I am able to find a subarray with sum equals to 0, then that submatrix can be a potential answer. Potential in the sense, if it has most number of elements, etc. because if you see 6 minus 6, 13 was actually row wise sum of 1, 2, 3, minus 3, minus 2, minus 1, 175, right? So if you see 1 plus 2 plus 3, minus 3, minus 2, minus 1 is 0, this sub matrix is 0. So if 6 minus 6 is also 0, this is also 0, you can see that this subarray is actually representing the sum of this matrix. So what is my goal? To find a subarray. My goal now is to find a subarray of maximum length such that its sum is 0. Alright, I think I'm clear right now. Okay, now ठीक. Now finding such a subarray, as I mentioned above, this is a new problem. Okay, so those who know this problem and are sure that they can code it, move to the code section where I will be writing the code. Okay, otherwise you are welcome to understand what will be the algorithm for finding the subarray of maximum length whose sum is 0. For this, what we do, suppose we have a subarray, oh, sorry, we have an array like this: 2, 1, 3, minus 5, 6, then what can I say, 6, minus 1, minus 5, 0. Okay, how will we proceed? We will keep a counter sum initialized as 0. We will keep a map initially empty, and we will keep a I here. Okay, we will put start as minus 1 initially, end as minus 1 initially, and max length as 0 initially. Okay, because we have not got any indexes from where a subarray can start or end. Okay, what we are doing, if some we are traversing the array for I 0 to n minus 1, first step would be to upgrade a sum. All right, sum contains now 2. Then we check if sum equals to 0. That means sum from the elements 2, from the element 0 up till that ith element, like suppose this is I here, then if sum is equal to this is the maximum subarray length up till I. So what we will do, we will upgrade a max length as I plus 1, start as 0, and end as I. Okay, else if ARRI is equals to 0 and max length is equals to 0, in that case, suppose in this case, suppose we have up till now I have reached here and we have not found any subarray of length of any subarray with some 0. In that case, we will treat this as subarray. This is also a subarray, no? So what we are doing here, if ARRI equal to 0 and max length equals to 0, then what we do, then max length will become equals to 1, start will become equals to I, and end will be equals to I. Other than that, what we can do to optimize, I am saying, suppose the sum of elements up till this element is 2. Let's suppose, I am saying suppose, okay, and then I encounter a 2 again here. So when I encounter a 2 again here, I can say that if I have encountered 2 here, that means the sum of elements from, suppose, let me make it clear only: 0, 1, 1, 3, minus 2, minus 1. Okay, this is the element. Okay, so now I'm writing the sums here. It will be 0, then 1, then 2, then 5, then what can I say? 5 minus 2, 3, then 3 minus 1, 2. So now I have encountered 2 here, and then I have encountered 2 again here. So when I have encountered 2 here, can I say that this length, mm, this length is a subarray of length 0, subarray of sum 0? Because if 2 is up till here and 2 has come again here, so 3 will start from this, and you can also check 3 minus 2 minus 1 is equals to 0. This is the algorithm. Okay, so what we are doing, else if mp dot find sum is not equals to mp dot n, that means the element exists in the map, then if max length is less than I minus mp of sum plus 1, then max length will upgrade to this value, start will be mp of sum plus 1, end will be I, and then just if this is not the case, then what we will do, else mp of sum equals to I, just mark that I. Okay, at last return the max length, the sum, and etc etc. So without wasting any time, let's come down to the code, see how will it work. So what we were doing, we have to mark these will be the upper, downer, left and right boundaries of a final answer matrix. So initially I'm marking them as -1, f left equals to -1. Then if int, this is the size of the matrix right now, it is also 0 right now. So now for int left equals to 0, let me also take a reference of row and column here, equals to a dot size int col equals to a of 0 dot size, yeah, in left equals to 0, left will go up till call left plus plus, then vector of int temp of size row 0. This is the temporary array to store the row wise answers. We calculated the row wise sums. This temporary array will be used for that. Okay, now for int right equals to left, right less than left, right plus plus, right and left will together comprise to form the subarrays. Okay, the column wise subarrays which was spread along the rows. Okay, now what we will do, we will upgrade temp to store the row wise sums. I plus plus temp plus equals to a of I, right. Okay, after that what we will do, we will create a vector to store our results from the function which will calculate the subarrays with 0 sum. Okay, vector of int result equals to find 0, I'm naming that function 0, find 0, and I will send temp in it and row in it. Row is the size of the temp array. After that, let me write the function for find 0. Okay, what we are doing here, we are doing int start equals to minus 1 as discussed, end equals to minus 1 as discussed, and max length equals to 0 as discussed. Now declared a unordered map to store the sums and declared a sum as 0. Now for int I equals to 0, I will go up till n I plus plus. First step was to sum upgradation temp I. If temp I equals 0 and max length equals 0, in that case, in that case max length will upgrade to 1, start will be I, and end will be I. Second case is if sum equals 0, then max length will be I plus 1, start will be 0, and end will be I. Okay. If mp dot find sum is not equals to mp dot end, and if max length is less than I minus mp of sum plus 1, then max length will be upgraded to I minus mp of sum plus 1, start would be mp of sum plus 1, and end would be of I. So now else will come, else mp of sum equals I. Now after that, if max length is equal to 0, in that case return 0 minus 1 minus 1, that is no subarray with sum 0 is present, else return 1, that subarray is present and it is starting from start and ending at end. Okay, now what? Now let me make some space here. Let me zoom it down for you. We have got a result. If result first index is 0 is 1, that means we were able to find a subarray with sum 0. In that case, our up would be result of 1 and our down would be result of 2, and our elements present now would be equals to down minus up plus 1 multiplied by right minus left plus 1. If f of ELE is less than ELE, in that case upgrade the existing credentials. F of down becomes down, f of left becomes left, f of right becomes right, and f of up becomes up. Okay, now what? Now let me decrease this space because indexing is not a cup of tea sometimes in programming. Now after the loop, if we have to declare a vector for answer now, so first declare the vector for answer. Now let me create some space. Okay, so now if FELE equals to 0, that means there is no submatrix with sum equals to 0. In that case, return answer. Else for int I equals to f of up, I equals to f of down, I plus plus, and with j will go declare a vector. J will go from f of left, j up will go up to f of right, column dot push back a of I comma j, and then answer dot push back column. After that, return the answer. I hope it will work. The code was actually lengthy this time. There has been an error. Start equals to minus. Okay, start equals to minus. Or the line 28. It would be 0. Sorry, typing mistake. Another mistake. I don't think it should have been. Another mistake. There has been. Spelling of return. Classic spelling mistakes. Every coder has to make. Again an error. Temp plus. Oh, it will be temp of I plus. Okay, so let's see the compile and run now. I fixed every error. So compile and run. Running. Let's cross our fingers for the submit also. Thank God it has been submitted. Okay guys, thank you for your support. Thank you guys. It was a lot of fun solving these problems. This problem was such a roller coaster ride, and I love solving it. Honestly, it has improved my DSA skills, and I'm sure that it will be improving your DSA skills too. So please stay tuned for more updates, and I would rest my voice. And please, if you like the video, don't forget to subscribe for more such amazing content. See you later.